for this one, you're using rectifier and the inverter together. So because whatever in the wind power, right? In the wind turbine, if it's let's say just 100 kVA, this generator, you need to use a rectifier inverter combination, probably around 110 to 125 kVA. But the control is simple. So you might use gearbox. You might not use the gearbox. All you have to required is you have this. So doesn't matter the wind speed as long as above the cutting speed and below the cutout. That's for the safety operation. This one will be working perfectly. And for double feed induction generator, you just need to use. You also need to use this rectifier and the inverter combination. But for this 100 kVA, you might just use 35 to 40 kVA, smaller size, right? So we save you money, but it's a much more, it will be more complex control required. Because this control, they try to feed something into the rotor. They also have to monitor the wind turbine, the speed, everything, and it will be pretty much a lot of actual control component, everything in there. That's why we still consider this is the best. Yeah, your rotor is connected to the rotor, has the connection to the grid, but it's through this rectifier and inverter. So you generate the voltage on the stator. At the same time, stator going to feed to the grid, and you're going to taking that power, you're going to change it into different frequency, different voltage, feed back into the rotor to matching whatever the wind speed is. No, this is considered single feed generator. The soft starter is for, usually when you're talking about motor, you're talking about soft starter. But here we're talking about generator. So you could use a square cage, or you could just basically use synchronized generator. The soft starter only talking about motor because the soft starter, what we're talking about is for you try to reduce the large inrush current caused by the large size motor. Yeah. It's because when you put this in there, doesn't matter how the wind speed changes, you can from the rotor part or from the state part, you can have anything. Let's say you will generate between 200 volts and maybe 20 hertz, all the way to 800 volts, 80 hertz. You feed into this combination, you always come out 600 volts, 60 hertz. Yeah, for double feed, then you have to feed different frequency things into the rotor, and at the same time, you have to monitor the speed because at the different wind speed, you need to feed a different frequency in there. If the speed is higher, you need to feed the opposite direction, the AC in there. But the speed is lower, you need to feed the positive direction, the AC into the rotor. That's why it's a much more complex controls. Whereas the first one, you don't really care as long as the rotor is moving, you will generate something. Okay, you guys have any questions? Yeah, good morning. No question? Everything's good? Happy Monday. Yeah. Redraw. I don't like to draw them. I better open the PowerPoint. My drawing is terrible. I usually tell guys I didn't go to the art school, so I cannot draw a perfect something for you to see it. So this piece of drawing in your PowerPoint, this is a double feed induction generator. You will have a connection from the rotor. So your power is generated on the stator. This power feed to the grid. At the same time, you're going to feed some power back into the rotor. And you can, this control here, they have some kind of mechanical or electrical monitoring to monitor the speed. They also have to control the pitch angle, and then they will controlling the firing angle down here. Try to make sure. What? You finished 2 a.m. Then, if you have a single feed generator, so this is a single feed generator. You just need this wherever the mechanical power moving the blade, it will feed into this generator. Then this generator will generate a voltage. We don't care what's the voltage, what's the AC frequency. Then you go through the rectifier and the inverter, and the inverter will matching with whatever the gray voltage and frequency. So you can say this don't need a complex the control circuit in there. That's why we consider this one is better, because it's simple. But just those one need a large size, so you take up the space, maybe wherever you have to spend more money on them. And the score from that score learning, and basically you can try those online quiz. You, as long as you go through certain thing in the score learning, to make sure you will be able to do the online quiz. There's a question from the online quiz. No, because you, wherever the voltage generated, you already convert to DC, and your inverter going to be changed to the speed, to the frequency and the voltage matching to the gray. The output for your the output here is always fixed, because if your grid require how many volts, how many frequency, the output is a fixed number. The input here, that's why they call the variable voltage and the frequency, because the speed of this wind speed changes, the rotating speed of the rotor also changes for this single feed generator. That's why this voltage and the frequency output down here will be different, but down here will always be the same. The amps, yes, the amp could be changing, because if you have a very simple one, when the speed is changing, the wind speed changes, you might not be always producing the maximum power. your rotor speed is not just basically controlled by the rotor speed, the rotor of the generator. Some of them is directly connect onto the blade. You could control the pitch of the blade to try to always give you the different speed. Your blade pitch will change, so give you the best torque and speed optimize operation point to give you the maximum power. But you could also just have some basically down here. You don't care whether you have a fixed blade, and you just let it generate any type of voltage, because a larger one, for sure, you try to maximum your power, because you spend lots of money on industrial level or utilities level wind generator. You will always try to get the maximum power out. But if you just have a smaller one for your housing using, and for the blade pitch control, those one, just like some of the, let me find a different picture. So if you have this smaller wind turbine generator, they can all the way up to 100 kilowatts, right? For here, there's not too much thing in there. And also, if you have a vertical one, where the blade pitch control all those things, but you still, there's a vertical one for a smaller one. It's not so popular, but for the maybe a residential using, or just basically for your house use, you can have those one. You're not gonna have a blade pitch control or something. Just depends on the wind speed. So this way rotating, the rotor way rotating at a different speed, it will give you just any type of the output for this generator. But to matching whatever the grid requires, you got to put those rectifier and inverter. So at least I think tonight, you don't want to study all the way to 1 or 2 o'clock, right? You want to get some good rest. And tomorrow morning, you guys gonna have the exam. The exam gonna be starting, I believe, 7:30. Any question? Any other question? Yeah, just the control difference and the physical sizes. Another thing, let's say in third year, you learned all the reduced voltage starter, right? And before third year, you learned basically all the full voltage starter. you're starting a motor always using the line voltage, and which one is simple, which one is more complicated? Yeah, and as any person, like we electricians or any maintenance person, the simple stuff is always easy to maintain, to control, to replacing, even to do the repair. And for the more complex controls, everything, and you need more knowledge, you need more, even for the spare part, you need more to make sure you have the actual spare part ready if something goes wrong, right? Okay. Uh, Anything else? Oh, you just try to. Sometimes you don't need overthinking things, and unless you really going to working on those things, uh, here we just need you to know some basic thing about it. Yeah, you're welcome. Uh, should we go to the last one? So we're going to talking about micro hydro and hydrokinetic. Those are also considered renewable energy system. A micro hydro system, they basically use a synchronized generator, or another one you can consider just a single feed induction generator. Here's a generator. All you need is you have some water come down, and you can push the turbine to turn, and turning the turbine will cause the generator to rotate. The micro hydro sometimes depends on the system. They might need the mechanical governor to control the speed. Excuse me for a second. Oh, sorry for that. But because you always will have water flow down there, and we know the load connect onto the generator, because any generator, if you don't control the speed or you don't control the input power, when the load connect onto the generator, if the load varies, let's say you might have a 5 kilowatt generator down there. If you're only demanding 1 kilowatt of electrical power, or you're demanding the full 5 kilowatt electrical power, you will, because when the generator take on more loads, you will for sure try to slow the generator down. So sometimes you don't have a good mechanical governor to be able to supply the actual power to push, because the micro hydro, you don't have those very complex control as a utility, those hydro generator, right? So what they usually do is they will have almost like a fixed speed rotation down there to generate the maximum power. But if you only require 1 kilowatt of power, like the example we gave you before, you will have something, usually is an electrical space heater or electrical water heater. You will just put that actual 4 kilowatt to those space heater or water heater. So you will keep the speed of this generator running at the maximum speed. It's not going to vary in the speed too much, because if you will vary in the speed, you're going to change in the voltage and the frequency. The code gave you some definition in there. They call the hydraulic turbine device convert kinetic and potential energy from flowing water to the mechanical energy. That mechanical energy going to move in the turbine, and that turbine is directly connect onto the rotor. So you're gonna generate a voltage. Typical those micro hydro generator system, they will have a water intake. So that water intake is usually you will have you might have a smaller hill, you have a creek, the water is flowing down from the top. So you will not try to build the dam on that creek or anywhere, but you will try to take that advantage of water have a different heights from the top flowing down. Then you will use some kind of maybe a pipe or a sidle stream. You will make sure the water can flow into your can flow into where you want them to push the generator. The 4-bay tank is because from those creek or from those smaller river, you will have all different type of maybe sands, maybe some kind of debris. Maybe you have some tree branches or leaves, and you don't want those things to go to your generator because it's gonna jam your turbine or something. So the 4-bay bank is kind of like a place you will let those all other debris or sands to settle down there, and you will have maybe some kind of screen to filter out those things. Then the penstock is from that 4-bay bank. You just let the clean water go to your turbine and generator. The powerhouse is where the turbine or generator located. So later on, we can show you some picture. Basically, you can just have a shade, smaller area, put your generator inside. This one, they have a 2 generator down here, so they build a slightly bigger room down here. The tail race is where, because the water push the turbine, then you have to let the water after push the turbine go back to wherever the creek or river is. So it said typically automatic controller operating turbine, the inlet valve to maintain the constant speed and the frequency when the load change on the generator. Because because you try to matching that whatever the speed and the frequency and the voltage matching to the utility grid, or even you don't have that thing. You have a stand-alone system, but most load, let's say, you might have a kind of electrical appliance at your home, but those appliances, or you have a computer, or you have a other type of device, they still mainly they require the voltage and the frequency in your local area. So the automatic controls is try to maintain the rotating speed. If the load require more, they will let more water in. More water in, you will be controlling more mechanical power input. But usually those governor is using a large hydro generator, and for the smaller one, you might not have those very complex governors. And so in here they said if your load changes, they might have a load bank automatic control to the connect to the generator to dissipate energy. So that's considered dump load. And in the code book, we can say what is said. Because if you don't have those controller to or governor to control to regulate the rotating speed of this generator, you will just basically use some dump load to dissipate the actual energy. And for those micro hydro, it's there's a video you guys can search on the YouTube. There's people building those micro hydro themselves. Still, you need to get a permit because in Canada you can't take in any land water or any water without get a permit from the government. But let's say for your own house, you're gonna use a micro hydro generator station. In your house, you sometimes let's say at the nighttime you might doing the cooking, you use an electrical stove, and your fridge is running, you're washing the dishes at the same time you're gonna washing the clothes, doing the dryer, all those things. You're gonna need more power. But sometimes maybe you just go to home, go to work, not like now you're working from home, then you didn't run any electrical appliance. So but there's still water goes down to generate power. And if you didn't use any of those power, and you're gonna causing something over voltage or over frequency to supply to your house. So that's why you need to put a downflow down there. The downflow controller, they requires to matching your the output of your. You don't need a permit for rainwater. But if you try to take water from a creek, from a smaller river, from anything, just the surface flowing water, or even the underground water, you need to get a permit. Or you might be facing some type of fines, or the city bylaw officer will come to your house, or the federal agent will come to your house to. I'm not sure if they're gonna bring the ruler. So here the example shows you This example, they using a three-phase motor, basically a square cage induction motor, and they turn into a generator. But the power required down here, because three-phase machine might be easy to find, it's smaller size. They require single-phase power down here. So they will have some type of converter, try to convert the three-phase power into single phase. Then they put the transformer to step the voltage down. But at the same time, here's the electrical load controller to matching. They have those ballast load or dump load. So if this they call it to the village, maybe to your house or wherever, if you requires more power down here, they will bring less power to here. But if you requires less power down here, they will bring more power to those ballast load. So this is a smaller run-of-river generator station. You don't need to build any dam or anything, and they will just taking the water from one side and let the water go through all those penstock to go to the generation station. Here's your asynchronous generator, and the water is pushing the turbine, and you will monitor. This is a closed loop controlling system, right? You will try to monitor everything to make sure you have the required power come out. So here is one built at Whistler. It's by one of the companies. They did that, and all the generator station just located in this smaller shade outside. So they are pretty small, depends on what you required. You can have a less than 50 kilowatts, and for those one, you're not gonna cause a large environmental impact like the big hydro dams. But if you try to connect onto the hydro system, you gotta follow in the document we're talking about last week. So this is a smaller micro hydro system. The water come down here. You're gonna push this turbine. Then the generator is also located in this kiosk. Then the water after that, the water will keep going down, and you might have those pump system down here. If you gonna using that water for something else, you might want to use a pump system, try to increase the pressure. So what's inside there? This is a generator. This is the turbine. The water gonna go through this pipe, try to push the turbine to turns, and the turbine is coupled onto the generator. So the generator is moving at a certain speed, then you can have the AC power generator down there. This is show you a control panel for that. The turbine panel is for controlling the monitoring the turbine moving speed, and because this is a grid connector system, so this part they have a lot of requirement. The BC Hydro required synchronized protection on there. This is a SCADA panel, is a monitor the whole system. This is a HMI display panel. We show you everything, how this generator running. We have a picture show you slightly later. A SCADA system is a supervisory control and data acquisition system. So they will control the operation of the device or equipment, but they also gonna send the real-time or static data to maybe a central control location, or maybe through a computer, have any type of they use a lot in industrial process. Do you guys you probably have to remember what a SCADA is? Yes. I'm not sure how many people here. Okay, 47 people here. This is on that. You can see here. This is for the hydro connection down there. So they will have a under voltage or unbalanced current, voltage unbalance. Yes, you need to know for that. Or your over or under frequency, they will have a bunch of lights or monitor or alarm signal if any of those things happens. So they will have a type of protection if you loss of the gray or phase, and monitor over under frequency and over and under voltage. This is the picture of the SCADA system. So they will monitor the voltage at the different phase and the current at the different phase, and the power or power factor, and they also monitor the pressure in the, you can see here the turbine. They will say what's the pressure before the turbine, what's the pressure down here, then go through different valves, what's the downstream pressures, and you can switch a bit between different screens. Here we tell you a bunch of other things. If your generator is running or not running, communications. So they provide performance and the static data for turbine flow rate, upstream, downstream pressure. So it depends on wherever the industrial process goes. This SCADA system is, I think, also in the wind turbine, we showed you a picture also in there. It's also a SCADA system. They try to monitor a wind farmer operation. So here's they're talking about because for the for larger BC hydro those generators, you probably usually you're gonna use a speed governor to control the rotating speed of those large generator. But in here, we just going to use some kind of power electronics like the rectifier and inverter. So it's easy to operate the generator when they have a arbitrary frequency, feed the output through an inverter. The inverter can controlling whatever required gray frequency and the voltage. So the smaller generator, you can use a permanent magnet alternator to produce. This is the wide AC. So because the speed of the water flowing might changing, so your turbine might turning at a different speed, you will generate a different frequency and the voltage AC. But then you use the rectifier inverter, same as we're talking about single phase induction generator in the wind turbine. So you will try to convert whatever required as the gray frequency and the voltage. So in this case, even your generator cannot running at a very high frequency, you still will be able to use the power they generate. So that's why they said it's they can let them run at the best speed to actual extraction of energy. The power, the frequency, and the voltage is controlled by those power electronic device instead of a generator. So that's why we consider them, it's the best for any type of situation, not only in the wind turbine. In here, most micro hydro system, you will just use the rectifier and the inverter because the micro hydro is not going to be have a very large power, so you will not use any type of like those W-fed induction generator in those type of situation. This is talking about code rules. We're gonna look at the code rule slightly later altogether. Here's something when we're talking about code rule, you will know. When you guys learn a motor in third year, you always learn the conductor capacity for continuous load have to be 125% of rated motor load, right? In here, the same thing for the generator, the conductor have a capacity is at least 125%. And but in this situation also require the insulator, the conductor insulator temperature rating have to be 90 degree. Different section of the code will be required to follow. Mostly we're going to look at section 64. This is not like a common micro hydro system, but it's using in, I think, here's a Lake Michigan. So what they try to do is they they have a somewhere slightly higher area. They build a water reservoir, and when you have a actual energy available on the power grid, they will they have a powerhouse down here. They were using this in as a pump. So they will pump the water from Lake Michigan up to the hill to store those water in the reservoirs. But when the demand on the power grid is larger, so now you require more power on the power grid, then they will just let the water flowing down to push the turbine. Now this part become a turbine generator. They're gonna generate the energy to supply to the power grid. So it's kind of way try to balance when you have a lower demand, you use it as a pump to pump the water, go to a reservoir, kind of like you store the energy in there. When the demand on the grid become bigger, so you will let the water flowing down to push the turbine. Now you have a generator station down there. You're gonna generate the power to supply to the grid demand. Next one, I'm gonna talk about hydrokinetic. Hydrokinetic is operating interconnected or standalone system. One or more hydrokinetic turbine converted the kinetic energy of flowing water into electrical energy. So this hydrokinetic system you can install in the river or you can install in the ocean as long as there's a underwater current. So the electrical system is including all the electrical equipment. Hydrokinetic potential, there's some research done. They considering the global hydrokinetic potential, ocean and tidal water current. It's about 7,800 gigawatt hour per year. In Canada, just the river current potential is about 15,000 megawatts. And the research paper was done by the Quebec Energy. So they consider in Quebec alone, because they have a big river, St. Lawrence River down there, the potential will be 500 to 700, 800, almost 800 megawatts. Ocean current potential, National Research Council of Canada, they list about Canada have a 191 potential site which you can have install those hydrokinetic energy system. They will those locations will have more than 1 megawatts each, and the total is 42,000 megawatts. Already lost interest. Here the research paper did by them to show you how much potential available in BC. We have 89 sites. We have an average of megawatts available down there. But there's a technology limitation down here. So for the river turbine, it's hard to find a location with all the right operation condition. The depths of the river or ocean have to higher deeper than 6 meters. The current speed have to be larger than 2 meters per second. Same thing like a wind turbine. You can only take in about the Benz limit still apply here because for any type of turbine to work, the upstream speed and the downstream speed, you still have to keep that movement because the movement you have to keep it down there, so you cannot take all the mechanical power available down there. And including the efficiency of all the equipment and those turbines, you pretty much calculate a smaller percentage of available energy down there. But they did the research. They said if those technology, everything will be reaching the stage we can use the energy. They consider the power can be generated at probably about 15 cents per kilowatt hour. BC here, we are lucky we have a lot of rain, so we have a lot of water dams built by the BC Hydro, and we get the power. It's pretty at a pretty low cost because we paying about 10 to 15 cents per kilowatt hour down here. But if you go to some other province or you go to states, they usually charge you at a much higher rate. So for 15 cents per kilowatt hour, it's not bad. For the ocean turbine, the conversion rate is almost the same. Like you're probably just going to catch a smaller percentage, but those it's always down there because the ocean water is always flowing down there. You can install large size of the generator turbine, and this energy is always available down there, but the technology is there's people doing research, the initial installation for those things, and now it's not perfect to do them. So mostly still in the development and the research stage. But if everything will be available down there, they consider the ocean can be generated the power at 11 cents per kilowatt hour. But you can say the starting up, the initial installation cost will be between 3,000 to 5,000 per kilowatts. There's an advantage and a disadvantage. So here are some important things, because for those hydrokinetic, you install in the water, you install in the ocean, it will be always water flowing down there. And so the output power will be more predictable and reliable than the wind power. The wind power, sometimes you have a wind, sometimes you don't. Only at a certain place, you might always have a wind. But in a river or ocean, the water always flowing and down there. It's also not like the wind power. You have to be building high towers. Those hydrokinetic, you put them under the water, so no overhead retaining structure. Sometimes you don't even need a civil engineer. They are discrete and even invisible because the most turbine component is submerged in the water. The problem in Canada here is because in the winter time, the river or the ocean surface can have a frozen problem. So if depends on how cold the weather gets, you might have to think about your system might not be able to running if everything is frozen. Here's a picture. This is a Quebec Hydro. They install that hydrokinetic turbine generator in St. Lawrence River. Okay, so three type of hydrokinetic turbine is pretty common. Vertical turbine, horizontal turbine. That's for sure. You guys, it's easy to see. Another one called oscillating foil hydrokinetic turbine. This one is the river or ocean current. We push those turbine to oscillating back and forth. The oscillating force, the moving linear movement can be through some kind of mechanical and electrical means to change into rotation movement. Then the rotation movement can be coupled into the generator to generate the electricity. So this is the three most common type. You better remember this, and probably gonna be ask you a question: what is or what not is a common or hydrokinetic turbine? This is some code requirement. If you have a standalone inverter, they permit to supply 120 volt to single phase 3-wire service, but you cannot supply any 240 volt loads. No multi-wire branch because this inverter is only output 120 volts. So that's some kind of code requirement in Appendix B to tell you need to put some kind of warning on there. You can only allow to supply 120 volt loads. You cannot use in single phase 3-wire branch circuit. Marking. We're going to talk about that in the code section. The conductor, most of those renewable energy generator, the conductor have to have a capacity no less than 125% of the full load rated current. Wire method have to follow section 12. So what type of wire you can use in different, usually you have to use the wire suitable for wet location. Disconnect means always required. We know that. That's the electricians. So here's in, I think in Appendix B, they show you typical renewable energy system. You can see here the supply authority. So in here, this is the BC Hydro's one, and we have the distributed resource, solar panel, fuel cell, micro hydro, hydrokinetic, or wind power. We have a disconnect mean down here, and you could be feeding DC or AC down here, depends. If you have a photovoltaic, you will feed in DC. If you have a micro hydro or wind turbine, you feed in the AC down here. Then you might have a interactive type of inverter to connect onto the hydro side. But on the hydro side is always AC. You also need a disconnect down here. So you might have a meter down here. And here's your main circuit breaker panel. And your local load is down here. And that's your hydro feeding, your meter, and your mean overcurrent device. They providing you another picture. For this one, you might use a PV system or any type of system. You have a storage device. The storage device could be a battery or other type of a storage device. Okay, so that's about it. For this micro hydro and hydrokinetic, you're not gonna have too much question on there, but I already told you a few important things. You have to know that probably gonna be showing on your exam. So it's 9 o'clock. You guys want to look at the code first, or you want to take a break first, then we come back to do the code? Okay, let's take a 15-minute break. We're back at 9:18. Then bring your code book back. Yes. So how many are you back here?
Yep.
Okay. So here the result I got from you guys' response. 24 people is actually here. 3 is not sure. 4 people's bodies here. Mine's not. So I saw Jeff made some adjustment to your modern building systems, Mark. Now he make you guys everyone pass the exam. A little adjustment. I think it's a lot. He's handling the mark out. Yeah, how can you mark went up so much? You guys have a 40 or 45 question before. So he probably taking few questions out. Okay. So you guys can see my code book down here, right? The code question gonna come from section 64, and there will be usually there will be few IP questions also from this section. The scope is applied to the installation of a renewable energy system, and special terminology. It will tell you a bunch of if you ever encounter anything you don't know, you can always check the terminology. In here, they're talking about controller. So you have a charge controller, diversion charge controller, diversion load controller, downflow controller. That's when we're talking about the micro hydro system. The downflow controller regulates the output power of a micro hydro system by adjusting the amount of energy flowing to the ballast load to compensate for mean load variation. They even talking about electronic governor and a fuel cell system. A system consider one or more fuel cell and associated equipment produce usable electricity. You got a portable, you got a stationary. So hydrokinetic power system operation and interconnection or standalone consists of one or more hydrokinetic turbine, convert the kinetic energy of flowing water into electrical energy. Then this one talking about interactive system. A power production system operate in parallel and can deliver power to another system, such as supply authority. So usually in the PV system. We're talking about interactive system. Is you can feed the extra power back into the supply authority. And if you don't know what an inverter is, they have a combination inverter power condition unit. They also have interactive inverter. And what's the definition of a power condition unit? Yes, you're only going to get the code question from section 64. I shouldn't say that. No, I shouldn't say that. So, like I told you before, I might ask you a generator, right? I would say maybe a wind generator, maybe a micro hydro generator, maybe a hydrokinetic generator is rated at how many kilowatts or how many kVAs, and what's the voltage output. Then what gonna be the flow current, or what gonna be the minimum required ampacity of the conductor, or what gonna be the size of the conductor will be used for this supply. So when we go through there, we will see. So your inverter have an input circuit. The input circuit is between the inverter and the battery in stand-alone, or the source and the inverter. The output circuit is the inverter and the panel board for the stand-alone, the inverter and the service equipment, or another power producer source. Wherever you saw a ballast load or dump load, they now all refer to this diversion load, a resistive device consisting of water or air, electrical heating element. The energy is diverted when more energy generated than required. So that's when we're talking about micro hydro. You need a dump load or ballast load or diversion load. It's all mean the same thing. On your IP, you got to be careful. There's lots of more those renewable energy question came with the photovoltaic. So first is down here. I'm not sure you will always say this question, but it's a big higher possibility. Photovoltaic modules, a complete environment protect the assembly of interconnected solar cell. So it could be a smaller panel, could be a large panel. They have application class. Class A module is unrestricted access module for use in solar photovoltaic system operating in excessive of 50 volt DC or excesses of 240 watts. Class B, restricted access module, where the module is inaccessible to the public. Class C, limited voltage, unrestricted access module, operating at a 50 volt less or 40 watts less. So that's the three common class application. Photovoltaic recombiner. Assembly of bus and the connections contain overcurrent protection, controlling switches, other equipment. Connect the output from a photovoltaic combiner together to creating output at a higher current and high voltage, or both. So an individual combiner might be connect one or two or few those PV panel or module together, but then you might have a recombiner to connect several combiner together to have a higher current and voltage. Okay, rated power for smaller wind turbine. When you're talking about the rated power for smaller wind turbine, is the wind turbine's maximum power output at a wind speed of 11 meter per second or less. So you are taking, if they ask you the rated power for a smaller wind turbine, that's where the maximum power output at which speed. Now this one we already talking about renewable energy. It's energy from the source, naturally replenishable, sunlight, wind, water, tide, geothermal. Larger wind system exceeding 100 kilowatts, smaller wind system up to and including 100 kilowatts. Okay, 64-058 over current protection. So this is in the general section. Circuit connected to the more than one electrical source shall have an overcurrent device located at so providing overcurrent protection from all sources. Excuse me. Subrule 4, overcurrent device such as a circuit breaker, if backfeeded, should be suitable for such operation. If you look at Appendix B, if you're using backfeed circuit breaker, they will consider as a suitable backfeed circuit breaker is if your circuit breaker cannot have a line and a low marking on it. So which means that circuit breaker can take power from either side. So that would be considered backfeed circuit breaker. You got to be careful. This one I think sometime pop up on your IP. It's not a sometime. Mostly, if you look at a circuit breaker, they will have an indication on them. They said, okay, here's your line connection, here's a load connection. But if you're using them for backfeed, because usually you have, let's say you have a PV system installed on your house, on the top of your roof, you will go through an inverter, then you will connect them the same into your main house panel down there. So you could be feeding the power from the inverter back into your panel. If you try to do that, you require a suitable backfeed circuit breaker. So that circuit breaker cannot have a labeling or marking on them, tell you this is the line connection, this is the load connection. If you want, we can look at the appendix B. So that's 64.0-058. Circuit breaker marked with line and low have been evaluated for connection only in the direction marking. And the circuit breaker without a line and low evaluated for connection in both directions. That's what they said, which one is suitable for backfeed. Because if you want to feed the power back into your panel through that circuit breaker, you cannot have the marking on there. Did I answer your question? Yeah, without the marking line and low is suitable. If they have a marking, okay, give me a second. Let's see, we go to okay, if you look at this picture on Appendix B, there's a picture called B64-4. So this will be pretty common connection for your, if you have a residential photovoltaic panel. So here's your module array. Then you have a combiner box, you have a disconnect switch, you have an interactive inverter. This is your main AC panel in your house. So your main AC panel in your house, the top of usually your hydropower coming in is from the top drop down, right? So you have a main circuit breaker on top, supply authority, your power supply is always came from down. So be careful. This question I heard pop up more than once on people's IP exam. I'm not supposed to tell you that, but you're probably gonna say this question on your IP. They will ask you, now you're gonna connect your PV panel into this, the output of the PV panel through the inverter to your main panel down here. So how you're gonna connect them in there? You're gonna use a backfeed circuit breaker. And this backfeed circuit breaker, usually they ask you on the IP is where this circuit breaker should be located. So this circuit breaker should be located on the opposite side of your main hydro supply. If you hydro supply from the top, this circuit breaker, the backfeed circuit breaker should be located at the bottom. That's a very common way to connect the residential PV panel. So for this, to go into this main panel, you need to use a backfeed circuit breaker. So this backfeed circuit breaker is because the circuit breaker in your panel, right? It's if you know the circuit breaker, you have those push in, or you have to those bolt-in circuit breaker. The inside is always a bolt on the bus bar. It's the opposite side to your hydro or utility supply. So if your utility supply or hydro supply from the top, this backfeed circuit breaker should be located at the bottom. So I heard this question pop up on your IP exam a lot. Excuse me. So you can have the power both from the hydro to feed in your load, or you can have this PV panel go through this backfeed circuit breaker to feed you the load in the house. So don't say I never told you any. Which side is the top, which side is the bottom. So if you have this panel here, which side is the top, which side is the bottom? So here's your residential panel. That's your main circuit breaker, right? That's your bus bar. Power. Here's your utility. Supply. You always come into the main circuit breaker, right? Then from the main circuit breaker, you usually have a single phase 3-wire. So you're gonna have a 2-pole circuit breaker because you have 2 hots in there. You have a line 1, line 2. Your neutral gonna go to your neutral bus bar. Here's your white wire. And neutral bus bar. And this will be your line 1 and the line 2. So here we have a circuit breaker mount on here. The circuit breaker, let's say, if you have a bolt on or push on, you will have a connection onto the bus bar. And here's your conductor. At the same time, you usually use Lumax in the house. You will have a wire. Let's see, a wire. That's your neutral. That's your line. And you will also have a bonding conductor. So this is the bonding. Let's go to your load somewhere. But if you have a PV system, you will have an inverter. And the output of your inverter, we put So this is the output of your PV system. This one will be your backfeed circuit breaker. So you try to get the power from this side, go on your bus bar. No, you cannot do that. If your inverter, depends on the inverter, right? If you have an inverter just for 120 volts, you will just do this. If you have the inverter is rated 120 to 40, you will use most of the time it will be a double pole circuit breaker. I shouldn't be draw this to probably we have a, if you have a double feed, here's your bus bar. So this is line 1, line 2. You will have a circuit breaker somehow. The top is connect on here. The bottom is connect on different line. And here's your line 1, line 2. It depends on the situation. So if your inverter can give you that, then you can have those double pole circuit breaker connect on there. But if your inverter only have 120 out, you can only connect onto one side. Or I think the code says you're allowed to have this kind of connection, even you only output 120 volts, but you cannot have 240 volts in this panel. So that depends on how you're gonna do this. But usually for residential, you always have those 240 volts. So if for residential, you probably cannot just have the same line connect onto the 2 circuit breaker at the same time. But here we're talking about where this backfeed circuit breaker should be located. So if your hydro come from the top, this circuit breaker have to be located at the bottom of this panel. So this is the opposite to where your supply is, utility supply is. That makes sense? Yes? No? Okay, good. Go back to the code rule. So that's this rule. The backfeed circuit breaker should be suitable for the operation is that circuit breaker. On top of that circuit breaker, So if you have a circuit breaker here, and usually this is the part you're going to connect onto the bus bar. And down here, you will have a screws to connect on your wire. This part will be either push on or you have a screw to connect onto the bus bar. So for this circuit breaker, here's your handle for the tripping. If they label line low, then you cannot use for the back feed. So not suitable for back feed. If a circuit breaker no labeling, no marking, then it's suitable for back feed. Disconnect means a disconnect means shall be provided to disconnect simultaneously all on-ground conductor supply from renewable energy power supply from all other insulated conductor in the building or other structure. So if you have a renewable energy system, you have to provide the disconnect means, and all the on-ground conductor have to be disconnected at the same time. The disconnect mean referred in subrule 1 shall be capable of being energized from both sides, indicating it's in the open, close. Provision for being locked in the open. Conform to section 14. Section 14 is talking about overcurrent protection. Open at the rated low, being closed with a 4 on the system. Located within side and within 9 meters of the equipment or integral to the equipment. So those are all required for this disconnect means. Also, a disconnect means shall be provided to disconnect equipment such as inverter, battery, and the charge controller from all on-ground conductor of all sources. So if your system uses inverters, batteries, or charge controllers, you have to provide a disconnect mean for them, because those equipment could be need maintenance or out of service, or you need to do some repair on them. So you need to be able to taking them out of the circuit without shut down the whole system. That's why you need a disconnect mean for them. Subrule 6, where the equipment is energized from more than one supply source, the disconnect means shall comply with 14414 or 14700. 14700 is a solid state device, should not be used as an isolation switch or disconnect means. So you cannot use those electronic solid state disconnect means. I'm going to go back. Subrule A, disconnect means shall be provided to disconnect a fuse from all source of supply. The fuse energized from both direction. So if you have a fuse for the renewable energy system, you have to provide the disconnect mean both sides of that fuse. Because normally a fusible disconnect means you can only disconnect a fuse from the supply side. So for the renewable energy system connection, you have to be able to disconnect that fuse to make that fuse dead or in the dead state, because you have a renewable energy system, so your fuse could have a power feeding from both sides. That's why you need a disconnect mean on both sides. So irregular fusible disconnect, the supply have to come from the top, right? Your load connect on the bottom. The fuse is on there, but your blade is only, if you turn out the fusible disconnect, you're only going to disconnect the top. So what it requires is, if that's the case, you're using this for, let's say you have a PV system or whatever connect down here. So you need to be either putting a secondary disconnect. So you're going to have another disconnect down here. Will be able to open down here, or you just have a connection with the installation of the fuse inside, and you're providing a disconnect on this side. At the same time, you're going to providing a disconnect on this side. So if you want to replace the fuse, you have to be open both sides. Just for the safety reason, right? So because if one of the fuse blow, you have to open the panel, you have to be able to take that fuse out. But without the secondary disconnect, the fuse still live. That's where this rule asks you. You should all know this. Disconnect mean for DC circuit should be marked for the purpose, right? Because the DC circuit, when you try to break the circuit, the arcing, everything will be much more severe than in AC circuit. So the DC overcurrent protection or disconnect mean is all rate different than the AC circuit. Okay. So 64-072 marking. All interactive system point of interconnection with other source shall be marked with the maximum AC output operating voltage and the current. So if you have an interactive system installed at the point of interconnection, you should provide in the AC output voltage and the current. Also, the marking referred in subrule 1 should be providing the disconnect means for each interconnected power source. So this is a rule talking about marking. Uh, 64-074. Building the structure with both utility power supply and the renewable energy system, where practicable, have the disconnect means grouped in according to 6-102. So if you have more than one supply, the best way is you put all those disconnect means everything together, so you can be easily to lock up your system or to de-energize your system. If the installation where such arrangement is not practicable, you need to have a permanent plug posted on or near each disconnect means, indicating the location of all other service box supply power to the building. This is also for the safety. So if you can group all the disconnect mean together, because when people go there to do maintenance or go there to do repair, the first thing is the code require, if possible, we always, you cannot work on energized system, right? So you group them together, you know, you saw them, you will try to de-energize the system from all the supply. But if you're not able to group them together, maybe one in the basement, or maybe one in one of the building room, another one in another building room, you have to post in a permanent plug to tell you there's more than one system and where the other system, the disconnect me is, because when people to do that, then they will know, okay, there's more than one supply. They need to disconnect from both sides. It's just for the safety. Otherwise, if you don't post them, then one guy go there, maybe like some of you guys don't read the question really careful, right? You only read the first words, fifth words, and the 10th words. Then you just, oh, I disconnect power from the hydro. Now it's safe for me to working on the system. Is that really safe? Probably not. Uh, 64-078, loss of interactive system power. The renewable energy shall be provided with a mean of detecting where the electrical production and the distribution network have become de-energized. So your system needs those type of things. Now feeding the electrical production and distribution network side of the powering of common coupling during this condition. That's what we're talking about anti-islanding requirement. So if the electrical utility lost power, you need to be able to detect that, and you cannot feed the power back on there. Subrule 2 tell you the renewable energy system remain in this state in the subrule 1, so that's anti-islanding. So if a utility lost power, you should remain disconnect from them until the normal voltage frequency of supply authority have been restored. And also, it permit to operate as a standalone system to supply the load have been disconnected from the production and the distribution network. So they allow you to supply the load in your house or in your building, but you cannot feed the power back. That's in the hydro's document we're talking about anti-islanding requirement. That's the same thing, right? Next one, the inverter. Maximum circuit loading, the maximum current of the inverter output circuit shall be the inverter continuous output current. The maximum current of a standalone inverter input circuit shall be the standalone continuous input current rating, where the inverter is production rated power at the lowest input voltage. So I believe you guys been encounter a problem. Let's say you have a 6 kilowatt inverter. It's rated for, let's say, 208 volts to 240 volts. What's the maximum current? A, 6 kilowatt divided by 240 volts. B, 6 kilowatt divided by 208 volts. C, I don't know.
B.
B is the right answer, right? Good. So C here is the way talking about before. We're talking about that PV panel. The inverter output of a standalone renewable energy system shall be permitted to supply 120 volt, single phase 3-wire 120/240 service equipment, a distribution panel. Provided that there are no 240 volt loads. So you cannot have 240 volt loads. There are no multi-wire branch circuit. So you cannot have something like a multi-wire branch circuit. The rating of an overcurrent device connected to the output of an inverter does not exceed the rating of a neutral bus in the service equipment. The equipment marked in computer legible permanent manner with a warning not to connect to multi-wire branch circuit. If using in a residential panel or residential situation, if you don't have those 240 volts, let's say you use gas the stove range, you use the gas clothes dryer. As long as you don't have 240 volt loads, it's okay. But if your house have any 240 volt loads, then sorry, you can't do that. So this interactive point of connection, why I want to say this one a little bit more is I hope you guys don't mind. This is that the IP question we're talking about, right? They will give you a pretty complicated situation. They said, oh, a residential house, you have a PV panel installed, you're using a backfeed circuit breaker, and you have an inverter. The inverter output, it goes through a backfeed circuit breaker, connect onto uh, so that's why you now easily to find the answer for that is if you just look at uh, the solar photovoltaic system, you couldn't see that answer. If you're just looking at the backfeed circuit breaker, you're not going to see the answer. If you're looking at the inverter, you're also not going to see very clearly. But in here, they will say the point of connection point positioned at the opposite end from the input feeder location or main circuit location. So this is where they tell you, or you can look at the picture, right? I showed you a picture. So you usually find the answer for that question down here. The point of connection positioned at the opposite end from the input feeder location or main circuit location. Solar photovoltaic system. Another hint I can give to you is I think this time the IP is made by the people from Ontario. So Ontario have a lot of photovoltaic system. They will ask you the question mainly is focused on this photovoltaic system. So here's that in addition to marking required given that rule we're talking about before, a permanent marking shall be provided at an accessible location at the disconnect mean for the photovoltaic output circuit, specifying the rate, the operating current, and voltage, the maximum photovoltaic source circuit voltage calculated according to 64202, 1 and 2, and the rated short circuit current. Also, photovoltaic system with rapid shutdown. Rapid shutdown, we're gonna show you a little bit later on. I think that day I probably mentioned a little bit. The rule is 64218. Provide with a permanent marking in accessible location, a disconnect mean for the photovoltaic circuit, stating the photovoltaic system is equipped with rapid shutdown. So most people go into first they want to disconnect system. They will always looking at the disconnect means. So if they saw, okay, you have a rapid shutdown, they can just go there to press the button. And they give you the size of the warning sign for that. Okay, so that rule, sub-rule 1, item B tell you the maximum circuit voltage calculate according to 64202, 1 and 2. So 1 is maximum photovoltaic source and output circuit voltage shall be the rated open circuit voltage of the power source multiplied by 125%. So we know the open circuit voltage is the maximum voltage a panel can output, right? But here, you calculate the voltage shall be the maximum source of that open circuit voltage multiplied by 125%. And also, notwithstanding sub-rule 1, the maximum source and output circuit voltage shall be permitted to be calculated use the rated open circuit voltage or the difference between 25 degree and the lowest expected daily minimum temperature, because the temperature varies can affect the output voltage. The photovoltaic cell, the temperature go higher and the output voltage will be lower, but the temperature go lower, the output voltage will be higher. So that's why they ask you, if you want to do the calculation, you can use the lowest expected daily minimum temperature to do the calculation. And the voltage temperature coefficient as specified by the manufacturer. So because you have to use the temperature coefficient to calculate the voltage. Most of the time, you wouldn't try to do those calculations because we are electricians. You already did so much calculation in the school, and you will try to just use the rated open voltage. Why you use those voltage is the maximum source output circuit voltage is used to determine the rating for the insulated conductor cable or those disconnect means. That's why you want to know what's the maximum voltage. Okay, sub-rule 5, the photovoltaic source output circuit and the equipment connect to within the circuit with a maximum voltage higher than 750 volts DC, but not exceeding 1500 volts DC, shall not be required to comply with rule in section 34 or 36 for those rules. We know section 36 is talking about high voltage. So if this photovoltaic circuit even higher than 750 volts, but as long as they're now exceeding 1500 volts, you don't have to follow those high voltage section code rule requirement. If you can meet the following rules, the installation is serviced only by qualified person. The qualified person is you or electricians. The installation exceeding 750 volt DC is inaccessible to public. So nobody else, like a non-qualified person, can have access to those equipment. The enclosure in which photovoltaic source output circuit exceeding 750 volt DC are presented and marked with the word danger, followed by the maximum rated voltage of the equipment. So if those panels or those combiner box or even an enclosure box contain those high voltage parts, you have the dangerous marking, you tell them what's going to be the voltage down there. You follow those things, then you don't have to follow the high voltage sections code rule. 64204 voltage drop, notwithstanding requirement for A-102, the photovoltaic output circuit and the photovoltaic source circuit conductor shall meet one of the following requirements. The voltage drop shall be considered acceptable where the conductor rate not less than 125% of the maximum available short circuit current of the solar system. So they requires not less than 125% of your short circuit current. (64204) ampere rating of photovoltaic source and output circuit. Subgroup B, not less than 125% of rated short circuit current of the photovoltaic source circuit. The voltage drop rule. So subgroup A-102 will tell you a bunch of things. They tell you about, I think it's a 3% for your, if you look at it here, the voltage drop in the installation based on the feeder or branch circuit, if knowing, otherwise shall be based on 80% of rating overload. So you're based on 80% of your circuit breaker. But they said your voltage drop shall not be exceed 3% in a feeder or branch circuit, 5% from the supply side of the consumer service. In Appendix D, they tell you how to calculate those voltage drop allowed, right? So you can get the, I think the conductor size, D3 is tell you what size of the conductor you can supply a load in how far away to not exceeding 3% in the feeder and the branch circuit. But down here, I think we are in this rule here, the voltage drop. So even that give you that requirement, your photovoltaic output circuit and the conductor shall meet one of the following requirements. The voltage drop shall be considered acceptable where the conductor are rated not less than 125% of the maximum available short circuit current for the solar photovoltaic system. So usually a normal system, you will say, okay, my load is required for 20 amps, right? You remember when you're doing the calculation for voltage drop, you just use that 20 amp to do your calculation, right? If you said, oh, I have a 240 volt load, I have a 20 amp, the load requires is the rate for 20 amp, or how many watts you find that current. Then you use that current in your D3 to find out how far you can go. But in this PV system, the current you cannot using because a PV panel you can supply load in all different type of situation. This is the source, so you have to using the short circuit current rating of that PV panel or PV module, then multiply by 125%. So you cannot just use rated current. You have to use that current multiply by 125% as the current to do your voltage drop calculation. So that's what they means, because the PV panel is a source. You might be overloading it slightly, but you have now been able to trip the circuit breaker or to protect your panel in that situation. So you got to be careful. You don't want to using a conductor too long to causing, especially you think when you're putting a load on a supply, if your load is drawing more current, you will causing the supply, if the source is not able to supply that current, you will causing the voltage drop on the source. When that voltage source got a voltage drop, then your load will the voltage on the load will become even more lower. But to meet the demand of the load, you will always try to draw more current. So that will cause a back loop down there to causing more voltage drop, causing more current to draw. That's why they try to preventing that, to ask you got to use 125% on there. Oops. Photovoltaic module application class use. The module marked with application A and C shall be permitted to be installed in a location access to public. We're talking about that A and C. C is less than 50 volts, less than 240 watts. A is, I believe, higher than that in the terminology part, right? So A is exceeding 50 volts and exceeding 240 watts, but have unrestricted access. Then they're talking about photovoltaic module marked with application class B shall not be permitted to installation access to public. Okay, what if a photovoltaic module does not have application class marking on them? Then do they allow to be installed in the location access to public or not? No. Tyler answered no. So to find that out, we need to go to Appendix B to look at. For the application of this rule, consider blah, blah. The bottom here, the module without application class marking are considered to be application class A. So if the module wasn't marked, then you will consider that application class A. So if class A is allowed to install in a location access to public. Yeah. You better don't do those on your exam, okay? to take the 50% chance. (64.212) insulation conductor marking color coding. Notwithstanding rules 4-0732, that's tell you the conductor color coding. DC photovoltaic output circuit insulated conductor and the source circuit insulated conductor installed between a module and the power condition unit of the DC system shall be color coded, or both. For 2-wire circuit, red for positive, black for negative. Or black insulated conductor manufactured with permanent surface printing indicating the polarity on the insulated conductor. So that's how they require the marking. 3-wire circuit, you have bipolar circuit, white, gray, or white with a colored strip for middle wire, identified as center tap, red for positive, black for negative. Same thing, black insulated conductor manufacturer permanent printing. Then down here, the insulated conductor labeling marking permitted in subrule 3. Subrule 3 is related to, okay, we better go through all of them. Subrule 2, the requirement for subrule 1 shall not be met by field marking or labeling. So you cannot just use a conductor, then you're just going to put some strip of red tape on top, or put some strip of black tape on top to say, okay, I meet the requirement. No, they shall not be met by field marking. But then they tell you, now with standing subrule 2, insulated conductor color coding for multi-conductor cable required in subrule 1 shall be permitted to made through suitable field labeling or marking. So basically, you cannot use individual conductor to just put a tape on them. But if those conductor is from multi-conductor cable, then you could be field marking them. Then subrule 4 tell you the insulated conductor label marking permitted in subrule 3 shall be made at every point where the separated insulated conductor are rendered accessible and visible by removing of the out jacket of the cable. So if you use the cable, multi-conductor cable, you use field labeling, then you should be label them at every point where you can access them, or where you're taking the jack off of the cable, you all have to marking them. Uh, 64-214. Oops. Sorry, guys. Nobody remind me. It's already 10:36. Guys want to go for lunch and come back at 11:36?
Sure.
Sorry, guys. I didn't look at the clock. Oh, you guys are so focused. I like you guys. Should we skip the lunch? Keep going? Okay, see you guys after lunch. We're gonna take a 1 hour lunch, come back at 11:36. Sorry. Probably not all day. Photovoltaic is the big section because we, from what I heard, you will have a more IP question from the photovoltaic. Other section is not going to be so complicated. Yeah, after that, yeah, just wherever you have a question, I will answer you. Okay, see you guys.